Okay, good morning everybody. Welcome to stream 3 of the Bristech conference. My name's Rick Chapman. As Nick kindly gave us a shout out, I'm here representing Invest Bristol and Bath. Very quick shameless plug time. We're here to help support the tech cluster, actually for two reasons. One, as Nick mentioned, to help new companies who are looking to establish offices and facilities here. Which helps grow the cluster, helps bring people from outside the cluster into the area, increases the talent pool here, and basically helps everybody in the future steal from the person who just moved in. The second thing that we do, equally as importantly, is companies that are already here, helping them to remain competitive. So actually doing cluster development work, helping companies network, learn from each other, work out where they can collaborate, where they can cooperate, and of course leaving them space potentially to directly compete with each other as well. So we see cluster development helping companies that are already here as a key part of our mission as well. If anybody wants to talk to me during the day about what we can do, how we can potentially work together, please do so. However, that's enough from me. We're here to listen to interesting talks, not to hear me rabble it on. So I'd like to introduce Steph Locke. I'd also like to ironically thank Steph because at this time of morning she's forcing me to try and attempt to say discombobulating. Steph, in her own words, is living the dream as a data scientist. It's not actually my dream, but good for you.
I even have a blazer at home.
But Steph is extremely active, not only in her day job as a data scientist, but also running meetups in Cardiff, helping facilitate an awful lot of extracurricular events as well. So is one of the real go-getters in the area. Without further ado, I'm going to leave Steph to tell us interesting stuff.
Okay, can everybody hear me fine? Good. So when the screen switches, we'll be able to get started. So to keep you all awake throughout the rest of the session, I always start off with a big black screen. Okay. That's scary. That's really scary. Wow. This really does not bode well for my demos. Okay, let me just quickly get some things up and running. Cool, you can't see the horror that is the masses and masses of tabs I usually have open. So we've got this and this. This is my presentation. And it's still gone terribly wrong, eh? This is for, so one or two of the speakers this morning when we all did our checks said, that all went very, very smoothly. So thank you, speakers. I appreciate the solid jinxing there. Okay, does anybody have a spare laptop with Docker installed? It's brave. I put it all on the internet because I'm used to these kind of things failing. So nobody has Docker, you got Docker installed? Yeah. Oh, okay. This is going to be an extra big challenge for me because I don't have the money for Macs. Oh. I'm Welsh. I'm not lucky. Awesome. Okay. Yeah. And no. The plus side, we will be able to see whether it is my dongle because it's USB-C. USB-C?
What have you got?
USB-C?
No.
No. Okay. Does anybody have a standard Thunderbolt, or do you have HDMI?
Yeah, I've got HDMI.
I'm used to the smaller MacBooks. Okay. So, I'm guessing if only one person has Docker and is willing to let me break their laptops, most of you are sensible. So we will. How many of you are using Docker in production? Okay. How many of you want to be using Docker because it's cool and new? Okay. And how many of you are here because your developers are talking about using Docker because it's cool and you're worried about where all your data is going to go? Okay, cool. And the rest of you was nothing else interesting? Yeah, okay. Okay, so the talk will be on, whilst that's getting set up, Docker is great, right? Because you can try something new in a nice container, and then when it all goes horribly wrong, you can kill it. This is one of the big reasons why I use Docker, is so that I don't break my machine. I'm not a developer by trade. I do a bit of development, a bit of database admin, a bit of infrastructure, anything necessary to get my job done. And that usually means I'm installing lots and lots of different things, and I used to end up having to reformat my PC on a regular basis because I broke things and I'm not a Mac user. And it's hopefully a bit more stable. So
right.
How do I get the Tinternet?
Oh, yeah, I think I'm connected. Go on, sis.
No, I mean like Chrome.
Oh, right.
I seriously never use Mac. Cool. Okay. The plus side is, if it goes wrong here, you guys can follow along on your phones. So it's stephlock.info, data docker discombobulating, data docker discombobulating, .html. Fingers crossed. And it works. Okay, now my beautiful assistant. I need it full screen,
Okay.
if you please. Seriously, Mac. When people show up to my pre-cons for teaching R and things, I can do Windows, I can do Linux, but I seriously don't have the money to try Mac and be able to support it. Okay. So, where were we? Big scary face to keep you awake as opposed to the big black screen. Okay. Yeah, I'm kind of insane, have too much free time, so I spend lots of time building up the community so that I can eat pizza and chat to people who know what I do for a living. You can find all my slide decks and stuff on GitHub, and I tweet and I blog and that kind of thing. So I already started extolling the wonder of Docker for not breaking my machine, which isn't going so well today. And I just want to take you through some of the principles of data, Docker, how they work together, show you some demos. Hopefully, I will show you how to, I'll need you here for the first bit, start up Docker, connect to the Azure, authenticate the device with Azure so that I can deploy a Docker machine on Azure with the command line, then do some demos using it. So if all of this works, I think I will deserve a prize for the for sacrificing the most lambs to the demo gods. Okay. Data. Data is super important. Your application is whizzy. It's pretty cool. People need it to be able to interface with the company. But the data is the real asset. A lot of people say that like Uber isn't a taxi company, it's a data company. They have fantastic assets there. And if we're building applications in Docker and we're not putting the data somewhere so that it's usable, then we're basically like venting all that important value into space. We don't want to do that. And this never delete, never surrender is probably, well, it was heavily influenced by Toy Soldiers. Who's seen Toy Soldiers? Yeah, okay. I might be showing my age. Never delete, never surrender. You want to keep your data for as long as possible. Don't let anybody tell you differently. that Data Protection Act about keeping it around for, only as long as is reasonable. Reasonable is what I say it is, which is forever. Okay. And apps. So I talk a lot about customer data, but we also have a lot of application level data, so the things needed to make it, customized, to show logos, things like that. That's all configuration. That's data too. That's pretty important. And also telemetry. I do a lot of working with data that comes off the back of our applications. It's important from who wants to do DevOps or is doing DevOps, right? You can't get better without measuring things. So you need that application telemetry, the things about where people are dropping off or how long pages took to load or the 404 errors. You need that. You need to be analyzing it. So that's important data that your application will generate that you need to store somewhere. If you're not storing it, you're missing a trick. You won't be able to get your application better in a scientific way. Okay, Docker. So as I said, I like it because it means I break less things. You contain all your code in it. It's quite easy to get started. And another thing I like, as well as not being able to break it, is you never have to patch it. You never have to go through configuration of things. You maybe set up a config file and then tell it to run and it spins up. This is great. This saves me lots of infrastructure and config work that I just don't want to have to do, and I don't have the time to do it. Okay, so locally, let's give this a go, shall we? We'll start with a local version. And is it F11 to go back to...
Hopefully, yeah.
No, that gives me my overview. Nope. How do I get out of full screen?
Is it, you want a terminal?
Yes.
Okay. Do you want that full screen?
Can I have them side by side so I know what I'm meant to run? I can actually use computers, I swear. Okay, I read the whole slide deck and everything.
I don't think I have, I'm on the latest version of it, so I don't have quite side by side.
So Windows can do something that Mac can't?
I think the latest versions can.
Okay. I even had 2 desktops going before my computer crashed, restarted, and...
Okay.
Great. Okay. So, Docker is theoretically pretty easy to get up and running. Here, what I'm going to do is I'm going to pull down a copy of an Ubuntu container. Not very interesting because you could have an Ubuntu VM, but it's usually a good place to start. Fingers crossed. Okay, so Ubuntu isn't the Ubuntu container isn't available. Are you on the Wi-Fi?
It should be if you want to this. It just might be the same Wi-Fi that everybody else is
using. What we can do? Do you have Ethernet?
Unless someone's got a dongle.
I have a dongle for that. Hopefully this won't be the dongle that breaks things. We have a dongle.
I have a dongle.
Okay, so usually when it can't find an image, a container, like the setup code for a container locally, it will go away to a repository and download them. These are also called registries. I usually use the public registry called Docker Hub, but if you have sensitive work apps, then you can have a private registry. You can basically host local definitive copies of containers for you to pull for development purposes, production, that kind of thing. So this would normally go, can't find it, going to download it, and then it would run it.
running, I guess. Try quitting it and doing it again.
If I press Control C, will I break things? Cool. Yes. Okay, so Docker run should pull it and then run it if it's not in use. Oh, now it's really thinking about it. Okay.
I have an Nginx image locally. That's about it.
Let's try doing some of the Docker machine stuff. Okay, so local doesn't work. Let's see if we can do remote in a bit. But some considerations before we go. We've got, I use Windows, can't afford Mac. Please tip me using Flatter on my blog. Those pounds will eventually make enough for a Mac. On Windows, it currently uses a virtual machine to run a Linux container, a Linux VM, which you can host Docker natively on. Pretty soon, you'll be able to run Docker natively in Windows 10, SQL Server 26, Windows Server 2016. It'll be nifty. Oh, and I found this. I kept just like downloading all these new whizzy images full of funky things, and you kind of have to clean up after yourself, otherwise you find your hard drives getting pretty big. So do regular recycling. Okay. The thing we're all here for, well, hopefully you weren't here for the demos. Right. The whole point of Docker is that you treat them like cattle, not like pets. Has anybody heard that phrase? Yeah, okay. Pets are things that you love, you take care of, you maintain, and you don't want them to die. Hopefully. Although men's opinions on the cats that have invaded their houses does seem to vary. Whereas cattle, you're just raising them to kill them. You know, they serve a purpose, and then they're gone. You don't cry over them. So Docker is meant to be like that. It's meant to be, you know, you notice a problem, instead of patching it, you just make a new version and kill the old one and put the new one in its place. That doesn't work very well if you had a container with a database in. You would have to patch it if something went wrong, or deploy some code to change it. And then if something went wrong, your machine restarted, your container would be gone, your data would be gone. That's bad. Okay, so Docker has this thing called external volumes. Basically, everything in Docker is meant to be self-contained. External volumes break that concept. They allow you to have a mapped network location to somewhere else on the host machine, or hopefully what my demos will do is use Azure file storage, because again, I don't want to have to look after virtual machines. I don't want to have to worry about resiliency of my data, you know, shipping it lots of places so it doesn't ever break and get lost. And I don't want to have to worry about running out of disk space. So I use Azure file storage, or you can use S3 or any other online file store to be able to store data. And Docker has a number of drivers to enable us to do that with a few of these different big file stores. Okay, how you do it is, so I use Docker just all command line. You create a volume, you give it a name. That name you'll then use when you create Docker containers. And you give it a driver, so by default it's a local file store on whatever machine you're creating a Docker container on. In this case I'm using Azure File. And then you give it the directory that it shares on. Okay. So, first things first, can I do this? So right now I'm just going to see if I can get all my code. And I only remembered one of my 3D words. Okie dokie. So. In my GitHub folder, I have some scripts. I'm going to go up a directory and do something bad. I do apologize if I break your machine as well.
It's a good time to tell you it's government property.
Right, before I hit enter, is this right? No? Ah, because I did that. Okay, so if I do that, will it work? Yeah? Fingers crossed. Nope. So, the plus side, what I should be able to do when it's not off the side. Oh no, and you don't have a delete button. Okay. That's not a forward slash. I have done that to boxes before with sudo, and I have broken them. That's a dot, right?
That's a dot.
That'll just work in this directory?
It should just work in this directory.
Okay. No. Okay, let's go up another level. See, you guys, I'm live typing and, I've broken the machine already and you guys are helping this poor gentleman here save his laptop. And there's still no delete. Okay, will that work? Yeah? Cool. Now let's give this another go. Oh. That's possibly because I'm using the wrong script. You might know Mandy Beasley.
I think I do. Can you tell what I work for?
Yeah. Just a bit of quick data mining on his history there. See, I even have a well thought out README. Something that you guys all should do. And it's the sample setup. Okay, now that's because I didn't use Okay, I think I'm just going to abandon this instead of continuing to force you guys into the horror of watching me type on a Mac and get everything working locally. and you visibly de-stressed there. That was good. Okay.
More nervous than you.
Okay, you don't have a Can you maximize that? In Windows, it'd be, Windows key in and up, and it would work. Okay. So imagine this is being run on Docker, on a container. So here, what I'm doing is I'm making a Docker container from one that I put on GitHub, on Docker Hub. That is called DDD Simple Writes. It's just a very simple container, and what I'm doing here is I'm connecting to an external volume. So I have a logs folder on Azure File Storage, and I'm making it available inside the container. Okay, maybe I shouldn't have this full screen so I can switch between the two. Can I just have this with the... Yeah, awesome. Yep. Okay, so what this file, this Docker container looks like. Will Control-Shift+ get me zoomed in?
Do you want to maximize the size?
Yes. Command+. Cool. Okay, so this is a very simple Docker file. What we're doing here is we're getting the Ubuntu container, and then we're doing some things on top of it. We're building some extra layers that are specific to what we want to do. So we're taking Ubuntu, we're making a logs folder. Now, if this doesn't already have an external volume, it'll use an internal one instead. So for development purposes, you can use an internal one in the Docker machine, and then when you go to production, you can just mount an external volume. And then we're doing a command. So here, when we run this Docker container, all it's going to do is write the hostname of the Docker. So it'll give us a horrible ID from the Docker container, and it'll just write to a test file. It should just append. So very, very simple. And then, once we had that, what we would do is we'd run it lots of times. You can use Docker Swarm, but for the purpose of... Okay, maybe I gave you a lot of documentation to follow up with, which will be more coherent than my demo failed presentation. Okay, so here is just my very, very bad, you don't do it this way, way of running some Docker containers. So I've just got, I'm making 3 different containers that are constantly killing themselves and restarting. What they do is they all write to the same file. Because I'm using external file storage, external to the containers, they can all be working simultaneously. So this is a very trivial example of scaling. But of course, they're all writing to the same file. Why is writing to the same file bad? Locking. Yes, locking is the biggest problem you're going to have when you're doing things like this. So I wouldn't recommend doing it like that. We can also add a reader because we can start reading off the file. So in this demo, you would just see a container with tail of the file, and all these other ones would be running in the background, and you would just get lots of new host names. And it would be glorious, and you would understand. But just pretend, for now, that you kind of get the gist. Okay. So we've done that, we've done that. We've done that. Okay. Writing to files. That's great if you want to write logging data. So if you're writing telemetry. You would, of course, do something sensible, like maybe write a log file per host name or something to avoid some locking. And because whatever system you're using to ingest your logs, if it can't ingest multiple files, then you need a better log ingestion tool. But that's a little bit trivial. It's just text. What if we want something like a database, like MySQL? I don't recommend MySQL. I recommend MariaDB if you're going that way, and preferably Postgres. But, people have MySQL. Okay, so to start a database, we're going to do something a little bit more complicated here. So we're going to set up a MySQL container. There's one available on Docker Hub, so you can just pull it. And what we're going to do is we're going to do some config. So we're going to mount one of our external file stores to the directory where all the MySQL data lives. And we can expose a port. We can set environment variables. So here I'm setting my password as my password. One wouldn't do that. And you can also generate a random root password with a flag. So if you're building a database container and an application that's designed to just talk to that database, and you don't need to get the data out without navigating into the box, then you can just generate a random password that only the container that connects to it knows for security. We can give it a name. All quite cool. So if you had a blank directory and you ran this for the first time, it would go away and create all the data files that a standard MySQL database without any custom data in would create, which would be good. Then, if you killed that and needed to start again, you could attach using this same command to the same, and it would attach to the same data. So you can make a database that is restartable. Using external file data, it would still be in Docker, but that's still a single database. The whole point of Docker is you can go scale, you can do thousands and thousands of containers. We're the next Netflix. We're meant to be big and scaling. If you have a single database, well, that's just a low-balanced front end on the same big monolithic database that you all hate because you can't get enough throughput and the DBAs tell you off for, changing columns on the fly. You don't want to do that. Especially because if you try doing it multiple times, so if you had multiple containers and try to get around the locking contention, you'd come up against locking and write contention. MySQL is just like, I want all the things. So if you try and make a second one, then it would fail. And one of the demos would have been to see what happened and to see the log output where it goes, hey, I can't touch these files. I can't work on them. So you can't just spin up multiple instances against the same data. You need to think about it a bit differently. How much time do I have? 20 minutes? 15 minutes. Okay. So one thing you could do is per instance databases. So especially if you have lots of business customers, this is in particularly a good approach because most business customers want their data kept separate from all the other businesses. You might have data protection requirements, so you might have some US customers who only want their data in the US and not allowed to go out from there. So you could give everybody their own little sort of n-tier architecture in Docker and then be able to migrate all their various containers to different locations, give them their own resources based on how much that customer uses and how much that customer pays. It keeps all their data entirely separate, great from a security perspective for those customers. And it means that you can roll data out, roll changes out. So if you have a single database and you want to make a change to a stored procedure to go with your application, but some of your customers want monthly releases, whereas you want to go really fast and you want to do changes all the time, if you rolled out the container, if you made the change globally, then everybody would be affected, or you have to use feature flags. If you had basically an n-tier architecture for every customer, then you could kill and restart their containers in a rolling fashion to roll out the changes, to only when they require them. This, of course, allows you also to do deploy and revert. So if you're doing very cool things with your telemetry on your application, and you were able to start rolling out the changes, you could say, well, this is erroring for a lot of people, or drop-off is greatly increased. Let's revert that change. You can do that with a bunch of different variants. So there is quite a lot of advantage to having individual n-tiers for all of your customers. But it means that you have a lot more containers to work with. And I realized I didn't explain n-tier architectures. Who knows what that means when I say that? Okay, and I apologize that I said it so many times before asking. So an n-tier architecture is where you have n different layers. So you have your front end, you might have some middle tiers like API frameworks and stuff, and and usually a database under the hood. So you have, instead of having everything on one box, you make it usually into 3 different boxes so that you can scale each one to the size it requires. So it's not all self-contained. So it's not a one-tier system where everything's bundled and uses like SQLite in the background. It's everything split out into separate components, where that number of components could be n. It's great to be able to move fast with your applications. It makes it quite easy to build separate data pots for each customer, but then you have separate data pots for each customer. So if you ever want to do anything across customers, then you have a problem. Now, depending on your model, in terms of your business model, that might not be a problem. If you're not allowed to access somebody else's data for analytical purposes, then it's okay. But you will need to fit. This architecture isn't for you if you want to produce global reporting over the top of customer info. The other option is use somebody else's machine. I like this approach. I try and use as little hardware as possible because you can see the effect I have on it. I don't want to do patching. You could also see how badly I do at permissions. So I don't want to worry about those. So if I use database as a service, so something like Azure SQL, BigQuery, RDS, anything where I can store lots of data and get reasonable amount of scale, then I completely circumvent trying to persist data in Docker. That's pretty cool in the sense that I don't have to worry about it. I can just write my container, have a config string to wherever it's meant to hit, but then I've got latency issues. I've also got cloud costs, potential vendor lock-in. There are some issues there that you'd need to take into account. But it's great if you just want to move a bit faster. And you can do things like, you can still do a multi-tenant architecture with database as a service. So you can still have logical separation and physical separation of customer data in them. So none of these architectures kind of preclude the others to suit your requirements. And then perhaps the most complicated Docker implementation is to have Docker containers that replicate themselves, and when one fails, spin up another one. So all your data is still in Docker containers, but they kind of make clones of themselves. This is much more complicated, but you can have a cluster of Docker containers, like Couchbase do this. So Couchbase is a good solution for if you want to keep everything in your containers. That has the advantage that you as the dev, the person writing stuff, has everything right there. You can test it locally. It becomes very simple to do that. And then when you make a database change, the change basically replicates through the clusters. So it's a bit less work than using something like Flyway to change the schema when you deploy a new version of the app. Onto schema changes, because we make change. If you're using a relational database, even if you're using JSON, you might be very sensible and be using a JSON schema. You might need to make changes to that, and you have to store it and validate against it, so you've got to worry about versioning and stuff. I quite like Flyway as a platform agnostic database migration tool. I do prefer it when I can do database migrations in my code. So I'm quite a fan of like Alembic and SQL Alchemy with Python and stuff. That's cool. You can use something schemaless. So if you know NoSQL, you can document DB, Mongo, chuck it in and hope somebody understands what the hell you meant by it a couple of years later. I'm not cynical, I promise. When devs have a 2-year lifespan in a company, they don't usually get to see the fallout of badly stored data. Or you can have, you can use feature flags. So you can do changes that are non-destructive and just toggle whether that feature is enabled and active for customers. So you can have more refined releases and deploy slowly but surely. This is the area, because there are so many different architectural routes and where different ones will be right for you, that there's homework for if you want to take it that far. Okay. And who has their database under source control? Oh, who has database code that they write? Who writes stored procedures or anything for their applications? Okay. You guys know you can unit test stored procedures, right? And continuous integrate and deploy them and things. You can get smart with your database code. You can treat it like real code. You can. It can be real code. Okay, to summarize, thank you very much. I really appreciate that. I think only one person left throughout all my demo fails. The plus side is you can get the code and you can try it. And hopefully it'll work better for you. And I'm always interested in getting better with data in Docker. It's one of those things that I think needs to be really nailed down. More best practices, more failures broadcast, because knowing what not to do helps just as much as knowing what to do. So do talk to me on GitHub and Twitter, and especially if you want to extend my repo, go for it. I'll be very happy to see somebody doing a better version of this talk next year. That would be ace. So, questions. Do I have time for questions?
You do indeed.
I do. Okay. Question in the front.
We'll run through with the microphone.
MySQL example.
Mm-hmm.
You were connected to a MySQL. Was it running on the? Oh, sorry. In the MySQL example, you were connected to a MySQL instance. Was it running on the Docker image, that instance?
Yes, so the Docker container that I created, MyDB, used the MySQL image from Docker Hub to produce a one-off instance that I could use.
So if I deleted that instance, I would lose what's in the database?
If you didn't use an external volume to store the data. So that's how you persist the data and be able to kill containers at will, is you basically store it somewhere else.
Would it be possible to connect it to map the container port to my local machine port for the database?
Yeah, so if you run Docker, no. If you run Docker locally, it will give Docker containers an IP.
Okay.
I think. Or at least with running it on Windows. Because it creates them in a VM, I get a different IP, but I can still connect to it with and map to a port.
Okay.
So you could always do port forwarding if you wanted to. That would be how I'd fudge my way around that infrastructure challenge.
Yeah, that makes sense. Yeah. Thank you.
Yep. Any more? Man in the middle?
Hello. You began the talk by saying that data is like the lifeblood of anything. It's really important to keep our data and to use our data. And then we kind of moved on to the idea that you would spread your data across many nodes rather than having one monolithic database. There's somewhat of a kind of dichotomy there, maybe. Is there that? I mean, is that only acceptable if you simply can't look across a one view of all your data? Like that seems to be, if you can do that, it seems like that's a valuable thing to have.
Yeah, so if you use something like MySQL and have multi-tenant, then that is where the data, that's great for scenarios, especially where you want the data to be kept physically separate. I would usually, so my preference would be to pick something like DocumentDB or MongoDB and be able to push all the data into one big store. I like DocumentDB because Microsoft do all the partitioning and everything for me. So I'd have it in one big store, and then you could set access controls so that me as the analyst and the application as the customer can access specific records. So you can have a monolithic database, but we're using distributed technologies. Yes.
If there's anyone in the room who's earned the right to ask a question.
Since I can't use it, you can have it back.
No, it was a question to do with where you do go down the route of having a separate database for each customer. Can you mix in where you still have a single database? So I'm thinking of a central database for like maybe access controller. This customer is allowed to log into my system, but I'll keep their actual data separate.
Yes, because you can still do multiple layers. So if you had an application, you might put your authentication code and stuff in there. So you could then call your core authentication database to validate, and then your API would then go to the individual data store to get this customer-specific info.
Great, thank you.
Any more questions? Time for one more?
Yeah.
Gentleman in blue.
Yeah, do you have an experience running with other storage drivers that, for example, using S3 as a backend data store for MySQL? I could imagine there might be issues there.
No, I haven't used the S3 one, but I kind of just assume, Amazon, Azure, and Google, they're all going to be much of a muchness in terms of file stores because they'll expose the idea between the plugins, because it's all separately shipped in files, binaries that you can use. They're all designed to abstract away any differences, so they will work. But you might have to do, you might have internet connectivity issues and stuff like that. In which case, if your MySQL database container fails, if you have it set to always restart, if for some reason it crashed, it would just reattach to the data when it can.
Okay, looks like that's the end of the questions. First of all, I think before we wrap up the session, there's one person here who really deserves a hand, which is Alan.
Yes, our beautiful assistant people from the Environment Agency.
From this point on, they're available as a double act. So I'd like to thank Steph, but just before we depart, just to let you know what's going on in the rest of the building. In the next series of sessions, Waterside 3 down at the bottom, we have linking data on the web, hopefully a captive demo. In Cinema 1, we have how does platform as a service actually work. And here we have a very interestingly titled talk, Murphy versus Satan. I will leave it there to whet your appetites. But if you can make your way to whichever of those is your preferred session, we've got about 15 minutes to the start of the next session. Before you leave, if we can thank Steph.